In Lesson 7.3, we're looking at special right triangles. We'll use the properties for a 45, 45, 90 and a 30, 60, 90 triangle. How is triangle tiling used in wallpaper design? Triangle tiling is the process of laying copies of a single triangle next to each other to fill in an area. One type of triangle tiling is wallpaper tiling. There are exactly 17 types of triangle tiles that can be used for wallpaper tiling. Tile 4 is made up of two 45, 45, 90 triangles that form a square. This tile is rotated to make the wallpaper design shown at the right. Boom, boom, boom. If we draw the diagonal of a square, they labeled that D, the two triangles formed are isosceles right triangles. Here's our right angle, and these two sides have to be the same. Let x represent the side and d represent the measure of the hypotenuse. We can use Pythagorean theorem. D squared equals x squared plus x squared, so 2x squared. If we take the square root of both sides, we get the square root of 2x squared, which we could simplify as square root of 2 times square root of x squared. The square root of x squared is x. So our scale factor, if we know what x is, and we want to find d, all we'd have to do is multiply. So like if x was 5, d would be 5 square root of 2. We just looked at an algebraic proof for Theorem 7.6 in a 45, 45, 90 triangle. The length of the hypotenuse is square root of 2 times the length of a leg. The wallpaper in the figure can be divided into 4 equal quadrants so that each square contains 8 triangles. What is the area of one of the squares if the hypotenuse of each 45, 45, 90 triangle measures 7 square root of 2 millimeters? Okay, if this guy is 7 square root of 2, then the legs each have to be 7. And if that is 7, then this is 7. So the whole side of the square would be 7 plus 7, or 14. And the other side would also be 14. Area of a square is side squared, so 14 times 14 is 196. And my units were millimeters, and I'm finding area, so it's going to be millimeters squared. So on example 1, to find a leg, we had to take 7 square root of 2 divided by that square root of 2, that's our scale factor. Now this time, it's 8, but it doesn't have the square root of 2, rats. So to find A, we're going to take 8 divided by square root of 2, and we're going to have to rationalize the denominator. So take a times square root of 2 over square root of 2. So we have 8 square root of 2 over square root of 2 times square root of 2 is 2. So that's going to be 4 square root of 2. When we find our relationships for a 30, 60, 90 right triangle, we start off with an equilateral triangle. So originally all 3 angles were 60, and then we draw in the angle bisector, which also happens to be the median, since it's an isosceles triangle. And so we bisected the 60, which made 2 30s. And we could label these sides anything we wanted to, so we don't have fractions. They labeled this guy x, and then this guy is twice as big as that, so it's 2x. And then we use Pythagorean theorem to find our missing side of the right triangle. So we have a squared plus x squared equals hypotenuse squared, which is 2x squared. Notice I put parentheses around it because we need to square that too, as well as the x. So we have a squared plus x squared equals 4x squared. Subtract x squared from both sides, and then take the square root. Now the square root of 3 we're stuck with, but we can do the square root of x squared. It is x. So this time, if I know the shortest side, I can take it times square root of 3 to get the other leg. And we just did an algebraic proof for Theorem 7.7 in a 30, 60, 90 triangle. The length of the hypotenuse is twice the length of the shorter leg. The length of the longer leg is square root of 3 times the length of the shorter leg. Now, I wouldn't necessarily write all the words in your notes, but you do want this diagram. They ask us to find the length of QR. QR is our hypotenuse. I'm going to call that x, so we remember what we're looking for. So in my right triangle, the side opposite the smallest angle, remember, is the shortest side. So this is my, oh, they gave me the nice side. They gave me the just plain old A side. And so if I'm looking for the hypotenuse, I know the shortest leg, all I have to do is take my shortest leg and multiply it by 2. So even though they gave me an ugly looking number for my shortest leg, multiplying by 2 is not bad. So I get 8 square root of 3 over 3. Triangle WXY is a 30, 60, 90 right triangle with the right angle at X, and WX is the longer leg. Graph points X at -2, 7 and Y at -7, 7, and locate point W in quadrant 3. Now, if they'd said in quadrant 2, we would have made our imaginary line going up, but since they said quadrant 3, they made their little fake line going down because they don't know how long it needs to be yet. Now, you could use the distance formula, or we could use our amazing counting skills, and we find the length of our horizontal segment there is from -2 to -7 is 5 units. So that is our shortest leg. They want us to find the longer leg. Okay, that's not a problem. It's going to have to be 5 square root of 3 units long. Now, we're probably going to want that as a decimal to figure out where on the world that is. So exactly, we're at -2, and then my y-coordinate is 7 minus 5 square root of 3. But to actually plot that, I have no idea what that means unless it's a decimal. When I put that in the calculator and hit the magic change-o button, I get -1.66. So that would be about there-ish. And we can finish our triangle. Ta-da! We found 2 reference triangles in this lesson of 45, 45, 90. And there the measure is square root of 2 times the length of the legs to get the hypotenuse. So the measures of the sides are x, x, and x squared root of 2. And at 30, 60, 90, the measures of the sides are x, the longer leg, shortest leg is x, the longer leg is x squared root of 3, and the hypotenuse is 2x.